So this video explains how to use Excel to find the final temperature for all parts of this experiment, the thermochemistry experiment. You're going to do this for the part 1 where you add hot water to cold water, part 2 where you add the hot metal to the cold water, and 2 times in part 3, one where you add where you react the magnesium metal with the hydrochloric acid, and 2 the time when you react the magnesium oxide with the hydrochloric acid. So I've just made up some numbers here. This is my data. The first column, remember that in Excel, the first column is X and the second is Y. So first I graphed my time on the X-axis and the temperature on the Y-axis. That's this graph right here. So I just selected everything. Here, let me delete these and I'll show you how I got them. So I selected all the data points in the first column, and I just went to Insert, Scatter. Just pick this one right here, Scatter. Then I adjusted the axes again because Excel always starts at 0, 0. So once more, you go over here to View. Layout. Horizontal value axis, Format Selection, and I'm going to start at 0, which is here, but we want to end at 8, not 10. Alright, and then for the y-axis, I'm going to go to vertical value axis, Format Selection. Now here, we start at 22.1. And the highest we get to, my made up numbers here, looks like it's 36.7. So we'll make this 36.7. Actually, we want to go a little farther. Let's say 38 or so. So you want this to be a little bit higher than your highest number. I'll show you why. I don't like that. Let's try it a little bit higher. Make it 40. There. Alright, so you're going to want this graph, and you're going to, just like before, going to put a chart title above the chart, and the title is temperature versus time. And put your name underneath that. And then for the axis titles, horizontal axis, below the axis, this is time, and the units are minutes. For the vertical axis, rotated, this is temperature, and it's in degrees Celsius. That's one graph that you're going to want. You're going to print both of these out. Now, okay, notice how the temperature in yours look probably something like this. Temperature comes up and it's kind of steady and it goes down. You want where it first, from the highest point probably, to when it starts going down. So we're going to select, I selected this value, that time, down to here. Just copied it, Control C, pasted it over here, Control V, and then now I'm going to insert another graph, okay, where I graph this data, scatter plot, and now here, let's scale the axes. The y-axis is probably fine. The x-axis, we want to end at about 8 or so. So I'm going to go into layout, chart area, horizontal value axis, format selection, 0, fix, end at 8. I did the wrong thing. Whoops. I want that to be 0. And I want this one to be 8. There we go. That's much better. Now we're going to insert equation of the best fit straight line. And it's not that straight, but that's okay. So we're going to go into design. Over here, find the f of x right there. Put it in. Get rid of this stuff. Oh, and we started, yeah, okay, so we wanted this. So now, here's what we're going to do. Well, okay, let's fix the chart title. This is still temperature versus time. And my name's still. Still time, temperature. So now there's the equation of the best straight line. Remember, our goal here is to find, okay, where this line crosses the y-axis, because that will be our initial temperature. Or excuse me, a final temperature. That'll be the temperature that the system, the whole system ended up at. We could measure it because in our experiment there was loss of heat and it didn't happen instantaneously. So all we need to do here, okay, we want when x equals 0, okay, then y is just the y-intercept. So for me it'd be 38.19. This right here, your y-intercept, that will be your T sub f for that run.